Alright, for this section, we're working on solving quadratic equations over the set of complex numbers. We have a couple different methods to solve these. Quadratic formula, completing the square, factoring, and square root. This first equation, x plus 3 squared minus 100 equals negative 100, is already set up so that we could solve using square root, because we could take the square root of both sides to move on. We have one quantity being squared and no other x variables in the equation, so we can square root both sides to undo the second power. So on the left side, we're left with x plus 3. And on the right side, we're left with plus or minus the square root of negative 100. Because remember, when we undo something that's being squared, we need to include the negative square root and the positive square root. As we mentioned, this is the unit where we learned that negative roots can be converted to I times the absolute value of the root. So in this example, we're working with I times the square root of 100, which is 10. So we can leave it as plus or minus 10i on the right side. Left side is x plus 3. Minus 3 to both sides to get the final solution of x equals negative 3 plus or minus 10i. For number 2, we could also use square root. I'm going to work with number 17 and number 20 now because I'm going to continue using square root. So I subtract 20 to both sides to start off number 17. And we're left with 2x squared is equal to negative 20. Divide by 2 to both sides. We're left with x squared is equal to negative 10. Taking the square root of both sides, we get x equals the square root of negative 10 and plus or minus that value. Because we have a negative root, all we have to do is take out the I. So x equals plus or minus I root 10. Final solution. For number 20, same process. Start off by dividing by 3. And we're left with x plus 4 squared is equal to negative 9. Square rooting both sides. We're left with x plus 4 is equal to I root 9 plus or minus 10. So x plus 4 is equal to plus or minus 3i. Subtracting 4 from both sides, we're left with x is equal to negative 4 plus or minus 3i. Those are the two final solutions. Negative 4 plus 3i, negative 4 minus 3i. We cannot combine these to say negative 1i and negative 7i because we cannot combine the real and the imaginary parts together. So now I'm going to clear the board to have more space for numbers 18, 19, and 21. For these three problems, at first glance, it looks like I'm going to need to use the quadratic formula. As a reminder, quadratic formula is when I have a quadratic in standard form of a squared plus ax squared plus bx plus c equals 0. I can plug in these values to find the solutions into the quadratic formula of negative b plus or minus the square root of b squared minus 4ac all over 2x. So for number 18, the equation isn't set equal to 0, so I need to move the 9 over by adding 9, and now the equation is set equal to 0. Now I can solve using the quadratic formula. Negative 11 plus or minus the square root of 11 squared minus 4 times 4 times 9 all over 4 times 2. So at this point, we have negative 11 plus or minus the square root of 121 minus 144 all over 8. I'm going to move my work out to here. So negative 11 plus or minus the square root of negative 23 all over 8. Now this would have been the final solution prior to this unit, but because we have the square root of a negative number, we can simplify this down to being negative 11 plus or minus I root 23 over 8 as our final solution. I made a tiny mistake on number 19 that is a big mistake when it comes to the calculation. So I'm restarting it. In order to solve number 19, we could use one of two forms, factoring or quadratic formula. I'm going to keep with the quadratic formula, which as we said earlier, negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I were to rewrite this equation to use the quadratic formula, I need to make sure that my equation is set equal to 0. So I'm going to move the 13x and the 3 to the other side of the equation, which means I end up with an equation of 10x squared minus 13x minus 3 is equal to 0. Now this could factor out, and if I were to use factoring, I'd end up with the final factors of 5x plus 1 and 2x plus 3. Which means my final solutions will be negative 1/5 and, oh, sorry, that should be 2x minus 3. Negative 1/5 and positive 3/2. Now once again I'm using the quadratic formula, so I'm taking the a, the b, and the c values and plugging it into the formula. So we get negative 13 plus or minus the square root of negative 13 squared minus 4 times 10 times negative 3 all over the quantity of 2 times 10. So we end up with 13 plus or minus the square root of 169 plus 120. Because negative 4 times negative 3 is 12 times 10 is 120, all over 20. Which means we're working with 13 plus or minus the square root of 289 over 20, and the square root of 289 is 17. And at this point we have two equations, 13 plus 17 over 20 and 13 minus 17 over 20. 13 plus 17, that gives us 30 over 20, which reduces down to 3/2, which is that same first solution, or same solution that we had from factoring. 13 minus 17 over 20, that's negative 4 over 20, which is negative 1/5. Again, the same solution that we got from factoring. So either method we use, we get the same solution. But before I start combining like terms, what I need to do is expand everything out. So on the left side, I'm multiplying x minus 4 times x minus 2, which is x squared minus 6x plus 8. And on the right side, 3 times x minus 4 is 3x minus 12. Add 12 to both sides, minus 3x to both sides. Minus 3x plus 12. So we're left with x squared minus 9x plus 20 is equal to 0. This becomes factored nicely. X minus 5 times x minus 4. Setting both of those solutions equal to 0, we get the two final solutions of the equation. X equals 5 and x equals 4. Final solution, 4, 5.